a specific epistemology that is an understanding of knowledge and a way to find that knowledge. Now, according to me, there is even a third ontology, which is what I like to call a quantum ontology, which means that I believe that we're all highly interconnected, that the whole world is highly interconnected. And if that is my belief, which for instance is equally the belief of ecologists, maybe on another level, but actually they believe that we should be interested in ecologically responsible behavior since we're all interconnected. So if we kill the animals, it's bad for ourselves. Right? Now the result is of course the same. However, the scientific ontology that is behind is one that I would say is based on quantum mechanics. And I'll get back in a later lecture on that. The essence of science is not that it is something in the absolute. It is always part of a contemporary framework. You can only work on science that is available in the time frame that you live. I mean, if you would live 300 years ago, you would clearly have another view on science. What you try to do is you give a framework within which you can judge whether something is true, occurs regularly. That is sort of the purpose of science. And science and philosophy of science is always embedded in a history, in a sociology, in a country. It might surprise some, but there is an Islamic approach to science, which of course fits the Islamic history and the Islamic culture. Now that is equally valid as ours, it just fits another history and another culture. Now I would say there are four big groups of philosophical schools. There is the one that really comes out of philosophy, that is based on theories like critical rationalism, Popper's theory, on logical positivism, the Wiener Kreis, and whatever you can't measure doesn't exist. Kuhn's paradigms theory, who says it's all a paradigm. You do research that fits in the current paradigm, and if you try to do research that doesn't fit, it will not be appreciated. Up to critical theories that research is nothing more than a validation of a societal situation. Out of these classical philosophical approaches, we got approaches like deduction, induction, empiricism, etc. This is all the things you can find in any research methodology handbook. There's a whole different group of philosophers of science that probably could be labeled postmodern. That the basis for that is rather into architecture and arts, not into philosophy. Some names, very many French by the way, Derrida, Apostle, who is not French, Foucault, Deleuze, and Feyerabend, who is the best accepted philosopher of science, who actually says that any discovery that is made in the world is made against the ruling principles of science. And indeed, he says you can't even make a discovery if you don't go against the ruling principles. Now, there are a number of design consequences of that, and if you're interested into research, it's a good idea to have a look into all that. The third group of philosophy of science approaches is what I would like to call a neurobiological one, in which we find Maturana, Mingers, Varela, etc. I'll talk about all them, that really believe in a radical constructivism. Things don't exist. Things are constructed while they grow. Right? And of course, if you want to go for a constructivist research approach, that means that you're going to have one project, two projects, three projects, and each time you improve your project. And the end result, your last project, your last case, your last conceptual model will be the right one. And the fourth one, which I personally think is a separate one, is one that comes out of cognitive artificial intelligence and has to do with how the mind operates. It's a very exciting area, but it has to do with learning and how learning takes place. Now, very rapidly over the history of philosophy of science. In the prehistory, which is pre-Cartesian, pre-Galilean, before the 17th century, the church was a seat of science, and church was used, if you wanted, to confirm religion. And of course, that is what in the 17th to the 19th century some thinkers have opposed to. Right, and the best known probably is Descartes, who said, "I think, therefore I am," which is of course not true. You're equally if you don't think. So that is just a saying that unfortunately gave us for years and years a very peculiar view on what science would be and what is not science. So Cartesian thinking is based on experimentation. There is no role of the researcher anymore. The researcher is so-called, according to them, outside of the research, as if that would be possible. And it's based on an absolute Newtonian frame, which means a fixed absolute time and space concept. Everything is measurable. The big breakthroughs in the 20th century are, of course, relativity theory. And the interesting thing behind all that is that all those breakthroughs, what you had with science in the pre-Cartesian time was that science was reasonably holistic. What Descartes de Broglie was the end of a holistic view on science. Now, what you see in the 20th century is, of course, that step by step, that causality, that measurability is questioned. That starts, and it's not necessarily in chronological order, of course, with Einstein, who says objective measurement doesn't exist, it's all very relative. And quantum mechanics, and don't forget that Einstein was one of the founding fathers of quantum mechanics. Quantum mechanics even goes much further and says it is the observer who decides what exists. And then you have this famous double slit experiment. If you're not familiar with that, it's interesting to try and have a look on it. If you would like to understand within a quantum mechanical world how it works, you will have to use adapted research methodologies. And then in 1931 we got the famous Gödel theorem, which actually is kind of a box of Pandora, since Gödel, a very well-known and respected mathematician, proved that you will never find any axiomatic system, any symbolic system, that will accept or reject all statements. In other words, you will never via mathematics find the absolute truth. Now, for a mathematician, that's of course bad news. Interesting for Gödel is that he used self-reference in order to prove that. Proof is quite difficult since it's based on number theory, so he talks in numbers about numbers. Now, that's for decent people unfeasible, but the nice thing is that he really gets to the proof that he made. Another famous example of self-reference are the Escher drawings, the guy who can make water run up, and the way he does that is that he makes his own self-referring frame in which he tries to get used, so he makes a slight error in perspective, but it is so slight that you don't necessarily see it, and hence you go into his self-referential world. And in his self-referential world, he can have water that runs up. Now, if you're interested in self-reference, I really advise you to go into more depth into Gödel. Probably the best known philosopher of science is Popper, who introduced the principle of falsification. As long as science is nothing more than trying to do as many tests and to avoid as much falsifications, whenever you're able to falsify, then the hypothesis needs to be restricted, or you need to come up with another hypothesis. So science is an ever-growing thing, is an ever-changing thing. If anybody rejects your statement, then it grows, it continues. So any rejection actually is an improvement of science, right? There is no context of discovery. It's just a question of testing, accept, reject, and that's of course what you see in most of science, what is done today. Causality in that concept is a consequence of the methodology and not a concept in itself. So he did not claim causality. He came up with causality as a consequence of methodology, and that's quite important since causality will become an issue. Then you had Kuhn. Kuhn actually said it's all about the paradigm. You do science within a paradigm, and the only thing you check is whether what you claim fits within the paradigm. And after a number of years, 10, 20, 30, you'll see a paradigm shift, and then all the research that had been done isn't worth anything anymore. You get a whole new direction of research. So it's all about paradigms and your fit within the paradigm, right? Again, it's between Kuhn and Popper, I think